Well, it's been a few hours since I was working on this. I had to leave. I was working on this morning, and then I had to leave and go and do some work. Now it's late afternoon. I don't have much time before I got to head out again. But I figure the next thing I'll do is I'll check this this rectifier assembly. So basically, what this rectifier is it's going to be 3 diodes in this pack. And this obviously, the heat sink must be the output on this thing. So I think one diode is connected from one of these studs to the heat sink, another stud to the heat sink, another stud to the heat sink. So we should be able to get a reading on this just like on the other diode pack. Oops. Diode check. So I go to here. No reading. I'm not getting a reading anyway on this one. Alright, maybe I'm wrong about this. Let's check the diode pack and the one we just took apart. See if that's different. I'm not getting a reading anyway from this. That's weird. How about from... Okay. That's weird. Not sure exactly how this works. Alright. Not sure what I was doing wrong, but I just finally got a reading. I noticed that this is actually isolated from this side. So this side of the heatsink and this side of the heatsink, there's actually these plastic insulators right here. So even though they're physically held together, they're electrically isolated from each other. So we've got from here to here. In that direction we won't get anything. But then if we reverse the leads, there we go. I'm getting what looks like a diode. And then this one, same thing, or roughly the same thing. This one, same thing. And then if I reverse the leads, I get nothing on all 3 of those. And then interestingly enough, if I go to this side, I get nothing, but then I reverse the leads, and I get, again, all look like diodes. So in order to get this side to conduct to the center posts, I have to put the positive lead in the meter on here. And then in order to get this side to conduct, I have to put the negative lead in the meter on the center posts. Or was it? Did I get that wrong? Ah. There you go. Negative lead, positive lead. Alright. So that all seems like that's all acting like a bunch of diodes. So maybe there's 6 diodes in this thing. So let's take a look at the one we were just using and see if that one acts. Not getting anything there. Alright, that one, yes. 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 And now aha. This looks like a shorted diode, and this looks like... Now wait a minute, I just had something on there, now I don't. How come I'm not getting anything now? That's weird. Well, that's like a dead short right there on that center one. So I think what I'm going to do is I'm going to take this diode pack out and see how it acts on the bench. Alright, I've gone and removed that regulator module because we're going to fall out anyways, and the diode pack, and what I've determined is that this short screw here is just to attach this capacitor to the diode pack here, and then there's this long mounting screw, and then of course this goes over this stud, and that stud is your output right there. So I can check continuity between that stud and the frame, and it should be infinite resistance there. In other words, you don't want to get any kind of a reading here, because that would indicate that you've got a short between this stud and the case, which means this insulator would have failed, but that seems fine. The other thing I could do is I could check this capacitor for a short, this capacitor to the case. If you get a little bit of a reading at first and then it changes and starts going up, actually if you have a capacitance checker like I do on this, you can actually use that, or you can just change to the resistance scale, and you'll notice as I touch this, what happens is you get an initial reading and then it suddenly goes up. So what's happening is the battery in the meter momentarily charges the capacitor, and now it's fully charged. So to DC it looks like an open circuit. Once the capacitor is fully charged, it no longer lets the DC current flow. So now I'm going to ground this wire. I've now discharged the capacitor, so then I can do it again. Oh. Here we go. There it's charging. And that will just continue to go up until it becomes infinite resistance. And then if I touch it down, now you can see I'm grounding it out, discharging it. I can do it all over again. So that tells me this is not a shorted capacitor and it's not an open capacitor, and it does take a charge. So it seems to be doing what it's supposed to do. So that's one less thing I have to worry about. This is just a resistor. As long as it's not open, then we should be able to assume that it is also okay, and it is a, is that a 44, 48 ohm? Got a lot of corrosion on these parts, that's why I'm not getting a good reading on some of them. 43 ohm resistor. Again, that might have to do with noise cancellation. Not sure. But set that off to the side, and now we're going to look at our mystery diode pack, the one that appears to have something wrong with it. So I'm going to put this back on the diode check and see if we can't. Yeah, that is bad. You notice you're getting like a dead short no matter which way I put it. So what this is this is a bad diode. Of the several diodes that are in this unit, that one's bad. So that diode is good. This one is bad. That's bad. That one just seems open. That one's good. 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 Look at that. Dead short between these two. Dead short between these two posts. So you got some diodes in here that have shorted out. You can imagine what the effect would be of this. You take those two of these windings and short them against each other, and you can imagine what's going to happen. You're going to kill any power coming out of this. So this can go in the trash. I'm going to reuse this brush assembly. I'm just going to clean up the corrosion on here. The brushes are the same length as the ones on this greasy one.